And of course, you are always welcome to record any of this stuff. So as I was saying, what I do is I go into the parking lot and I basically use the same slopes if I can. I always start out trying to make it simple. And so I'll take this distance between these two lines, and then I would use that to calculate this slope. That slope, assuming that I do a mirror image to the other side, will be the same slope the other direction. The nice thing about knowing this slope is that then I can go perpendicular to find any point that I want. We don't need that one, by the way. We need the one down here on the tangent. So I can go perpendicular to get any point I want. And then, of course, I can do the same thing over here. I can go perpendicular to get any point I want. Does that make sense? And yeah. I think it has to be a much simpler method. Now, all of these lines that I'm drawing, of course, I take out later. It's also important that we make a note. This is a porch up here. It is the same elevation as the FFE. So we do not need all of those spot elevations for the porch.
Okay.
And I'm going to take those back out, and then we're going to talk about this little corner over here because it's up and everyone needs to be aware of how this works. Again, that's the porch. So what you really need is the spot elevations on the ground. And once you have those spot elevations on the ground, you need to have another one out here in the middle. Make sure that water is running away from the building, not onto this wall. If water running onto that wall is a definite no-no, and you'll lose points for it very quickly. The same is actually true for these corners as well. So you will want the spots outside, and of course you have the one out here, but you're going to want another one out here to make sure that water is running away from the building there.
Does that point in the middle just have to be lower than the corner elevations of the building? We don't have to calculate it specifically?
That point has to be lower than this one.
But we don't have to calculate it specifically.
No,
right?
You don't.
It's on there.
You don't have to calculate it specifically. That's the nice thing about this.
Okay, cool.
Nat is telling me to press record on my breakout room. It says it is recording. Nat, go ahead and talk to me if I'm not doing it correctly. In fact, just go ahead and talk to me anyway, because I want to make sure. I know you're here, Natalie. Hey, Nat, you there with me?
Yeah, what's up?
Is it recording?
Yeah, I see it's recording now.
Okay, thanks. So the answer to your question was this point here has to be the low one. No, you do not have to calculate it. You can make a reasonable estimate just to make sure that it's lower. That is an excellent question. Let's see. Do I need a sidewalk along the curb? I think everyone needs a sidewalk along the curb. And the reason is that otherwise people have to get their feet wet to get to these walkways. So if I pull my car in right here, and half the time it works and half the time it doesn't. If I pull my car in right there, then I get out of my car and someone's parked right there. Either I have to walk out in the road or I have to walk across the grass. So I think everybody should have a sidewalk right there, just as a courtesy to the folks that are living here. And likewise, a sidewalk down there. The good news is it doesn't make your grading any more complicated at all. The spots are all the same. There's nothing that goes up or down when you're doing that. I feel like I will run out of room. Yeah, there's a good chance of it. It gets really tight there. The 68, 67, 66, et cetera, contour up around the parking lot, and I'm doing something wrong with the spatial calculations. So first, let's talk about the spacing here. You're going to have to probably take this contour and push it back pretty tight in there. And the reason is that these other contours are going to come around. And your 70 is going that way, but I still think you may have a few more coming around here. I can't see all the numbers on your contours. Let's see. In fact, I can't see most of the contours on this plot. So one of the things we do need to do is figure out how to make these contours show up. So I think there's a 67 or something that comes in here. That one's going to have to come up and hit the building. So without seeing your contours to address that, I'm a little lost, but I tell you what, let's try to do it on another drawing when it comes up as well. You're down to a 68.4 here. The easy way to solve that, by the way, is to simply do a reversal at this point. Make this center line a mirror image. And so what happens is this contour will simply wrap around on the inside of the curb. And then you'll put a drain inlet in these two corners. That means your 69 definitely comes around the outside. Your 70 can connect to the other side. But let's remember to come back to that on another one. Is a swale necessary along the side of the building? Can I tie the contours into the building themselves? You can definitely tie the contours into the building. Most of you are finding that you'll need a little bit of a wall down here. And then your contours, for example, your 70 is going to come over and around. Your 69 is going to come over and around and tie into the building. Your 68, your 67, your 65 is already there. And again, I don't know where that 66 or 67 start. I'm just making a guess. But please note what I just did right here is wrong. We have water running into the building there. So that means that that contour must turn, and then there'll probably be another contour down here because you will be creating a swale down there. In all honesty, the swale is going to start up here somewhere, and so you can start to recognize that pattern all the way down, and you'll probably have a swale running down the whole length of that side of the building.
Okay. Spacing on like how the contours hit that building, if we did like a 5-foot interval, because it's a max, the side slope is a maximum of 20%. If we did like a 5 interval where it hits the building, would that be correct?
That's perfectly fine.
Okay.
At a 20%, I think it's actually a 1-to-4 ratio.
Well, that was the maximum, but I disagreed.
Yeah, that's exactly the sort of thing. You don't want the slopes next to the building being too steep. Are the patio elevations the same as the bottom FFE? Yes, they are. Are these FFEs good, or will the contours go away from the buildings? For the contours go away from the building. So that's a 72, so that works fine. So what's going to happen on this side is that 71 is going to run down this way, and at some point it's going to come across like that. And this one's going to come down, it's going to come across and then hit the building over here. So this is a 70. So I don't see a problem with your FFEs. I'm not sure you're going to get all the way up to 72 there. You may have to add a set of stairs to do that. Again, please remember the slope arrows go the other direction. But the real question is when we get to the back side with that 62. The reason that becomes a question, and it's hard to tell on this one because I can't see the contours, but if this is the 61, then my guess is that the 62 is running through this tree. Let's just see if we can find that on another person's drawing real quick. Nope. Nope. Yeah, we got a real issue with getting these contours to show up. All right, there I can see. So the 62 runs right through the middle of the tree, and the 63 is running up above it. So what that means is that if we go back over here, 62 is running right through, and the 63 is running like this. The difficulty is with that 62, you're going to want a 62 contour right there. Well, this 62 contour could probably come up, but if that was a 62 over here, which it is, then there's no way we're going to get that 62 to do this. It's just not going to work out. So that means that this one is not going to have a walkout basement. That also means that the 63 is going to come up and hit a wall there. The 64, look at that, I can see the 64. It's going to have to come up. The 65 is going to have to come up. The 66, wherever it is, there it is. So they're all going to have to come up. Well, that was interesting. And they're all going to come up and hit and we're going to have some sort of swale running down here. And you will want to curve that swale this direction.
Okay. And so the only ones, there's only the 2 buildings need the walkout basement, right?
Right, and you've got 3 of them doing it.
Okay, perfect.
So that one, and this one all have walkouts. That covered your question. Anything else I can address on this one?
I guess do I do the for the parking lot and the crowns and where my contours are, does that look like correct?
That looks correct. I can tell you how to check it pretty quick and easy though. If you've got a 2% running this direction and you come down and come back that way, that's my concern. That distance on that line right there should be, I believe, 6.25 feet. I believe that's correct. I have to go back and check the numbers again, because let's remember that 3 inches is equal to 0.25 feet, because there are 4 3 inches in 12. So 0.25 feet is what we're talking about. So the fact that you've got that at 45 degrees makes me a little concerned.
Okay.
My guess is that you should be, at a more gentle angle over there. This one, yeah. So you'll want to check that. But run the math real quick for me, if you don't mind. Let's see if an H and a V with this slope, see if those numbers match up for me or not. And if they do, that's great. And if they don't, well, it's been a fun day for me so far. While you're doing that, I'm going to move on to the next one, but we'll come back if we're wrong, you just sing it out and tell us what the right numbers are so we all get it. Aubrey, you with us?
Yeah, I am.
How do I approach solving the
elevation
or the curve? Okay, so what happens is you're going to need one. Whoops, hello, Stuart. You're going to need one here, here. You got those obviously figured out. So what happens, and this is a great question. It would be normal to say, oh, I'm just going to run this direction and figure out what that is. You can do that if you know that slope, but I think it's much easier to simply come straight over. And you know that that is a drop of 3 inches, is the same as a drop of we think it's a drop of 0.25. We have any confirmation on that? Yeah, it is. And so whatever your elevation is here, drop at 0.25 to get that one and this one. And then you've got good information, because if you know that, then we simply go back through. You know this slope, correct?
Yeah.
So if you've got a spot elevation at any point here, at any point, and let's suppose I want to solve for that one there. There's no reason I would want to, by the way. We're just using it as an example. All I have to do is come in, find that elevation there, and then subtract 0.25. And that gets it for me.
Okay. Yeah.
So those little tricks are nice. I am so confused. The crown that is supposed to be me here.
Supposed to be there.
Looks to me like you've got your crown going correctly. And the only issue is that you're so gentle in your slope over here that there's probably no additional spot elevation that's going to appear. Ah, yes, one of them may appear. So what you're going to do is you're going to take this percent slope, which is a 1.8, and you're going to find out if there is a 68 contour in here somewhere. And so that's actually, I'm looking at this contour and that spot elevation, and something's not quite working for me there. See what I'm saying?
Yeah.
So that tells me that something's not right between this A and your high point on the other end. So you got a 72 there, and this one, this B was given to you. We had one student, by the way, I can't remember who it is, but they took that B number and stuck it here in the middle. We'll get to that in a minute, or it's in Wulong's group. So you'll need to check that slope again, because if that is calculated correctly, then this would not be where the contour crosses, as you can see, because that's a 68.5. You follow what I'm saying?
Yeah, I don't think I calculated correctly.
Yeah, and also just to let you know, your labels are on the wrong side of the contour. I know it's early in the process, but the fact is it's really easy to forget that. Yeah. So I think something is amuck, and I don't agree with that contour. And you've got to figure out where those contours actually hit.
Okay, I will.
So with that 1.8% at this at the beginning of the drive, I know I have a similar number. Yep, and don't we I think, was it maybe last Tuesday where you were talking about having, if it was lower than 2, we had to have like a side slope on the drive?
You're going to have the side slope on the drive anyway, because you've got a 3-inch crown. So
how would we label that?
Any point here to there, you're going to have a 3-inch drop. And that's going to be true out here as well. You're going to have a 3-inch drop. And so you do not need to label that. We already know that it's a 3-inch crown, but your spot elevations do need to work with that. So for example, you will have a spot elevation here and here, because there's a tangent point there, which means you need to find this one and then subtract 0.25 to get the ones here in the corners.
Oh, so we wouldn't stop at so we would actually go to the actual property line and not the 5-foot offset?
Correct.
Okay.
Can you help me find the angle for the contours? Okay, I think we talked about that in the last review just a second ago.
Yeah, you did.
So did that cover it for you?
Not really. Yeah.
You want to do it again? Okay, so what you need to do is, let's just pick a point here in the middle. We're going to pick this point here, an arbitrary point. We know that this second spot now is 3 inches lower than that.
Yeah.
So 3 inches, which of course is equal to 0.25. The question is, if this slope is correct, how far do we have to go to get back up 0.25? So let me just roll out and find a blank piece over here. So if I'm going this direction, and let's call that a center line, and I have a point here, then I go sideways. And when I go sideways, I'm going to drop 0.25. Now the question becomes, and the question is equal to H, by the way, how far back up do I have to go to get this elevation the same as this elevation? Because once those elevations are the same, if they happen to be a whole number, that would be a contour. So the question is, with a slope of, I think it was a 2.3, is that what your slope was?
Mm-hmm.
And a V of 0.25, what is H? Because H will be this distance right between them. I'll draw it here again. H is right here. Once you have that established, then you can take that line and simply extend it on down. So for example, if this was the 72 location and we did that little calculation and it came back to here and we did that line, then we can simply extend that line straight down to the curve. So the question on this side would be, what would H be at a 2.8 slope? Does that help you?
Yeah, that makes sense.
Okie dokie. That's not a question. There's no need for a swale over here, by the way, guys. I know a lot of you have done that, but the fact is the water's running off by itself anyway. So there's no need for a swale there. You know, you're going to have, you know, something going along over here. You're probably going to have to put additional contour line in there to make sure you get water draining off. And you could either close it here, or you could even put a wall over there if you wanted. A lot of folks are putting the wall in there. Don't worry about exactly where that swale goes yet. You don't know until you get the other stuff worked out.
Okay.
Remember, when you put that 5% in, you need to give us an arrow so that we know that you know which way it's going. These spot elevations, assuming I've got a spot elevation here that's higher, and I'm not sure that you got water running away from that wall there, so you're going to have to add that spot there in the middle. I'm also concerned about why this one is higher than this one. And my guess is that you're starting to copy paste spot elevations, and that could be tragic. Whenever you want to copy a spot elevation, just have a few extra 0, spot elevations out there to copy around. That's going to be much more useful to you.
Okay.
Or the way you've done this one with ... That's brilliant, actually. 71 ... Yep. Very smart way to do it.
Okay.
But not so smart. And the reason is, you know, once they're in AutoCAD, they look so final that you have no idea what actually is. So I love your ... 64, 63, 64, 65. Yep. Those will all be able to work with walkouts. Any other questions?
I had one other one, but you already answered that one. So I think that's pretty much it.
It's there somewhere, but I already got it.
Yeah, you already got it.
Excellent. Nicholas, was my math correct? Nick?
Yeah, it was.
Okay. That's a nice change for me. Joe!
Hey, Stuart. So I realized that my annotations, I had them on AutoCAD in an invisible layer, so they didn't come through.
Well, that typically happens with invisible layers.
But I think like for the past, like I've been really paying attention to the past two, and most of my questions were answered. And I was watching you talk about the contour angles, and I haven't put my contour angles in just because I didn't quite understand it. And explaining it to Aubrey definitely helped. But the little triangle that you're drawing, I don't understand like how you're drawing.
Let's do it again. So let's assume that this point that you put in here is accurate.
Mm-hmm.
And then the question we're trying to figure out is, okay, what's the angle on that stupid contour that's going to come off of there? And to figure that out, we go out this direction to the edge of the striping, if you will. And the reason we can go to the edge of the striping is that the edge of the striping is the same width as, lovely, as the roadway here.
I gotcha.
So we refer to that as the driving aisle. And when we're over here in the middle of the parking lot, we use the same thing. Because what we know then is that there is a 3-inch drop from this point down to that point. You with me?
Got it.
Okay.
Yep,
So
I got it.
we take that knowledge back over to the center of the parking lot. And so we know that we have a 3-inch drop to here. That 3-inch, of course, is the same as 0.25. So if we've gone down 0.25, that means this elevation right here is going to be 70.75. Does that make sense?
Yep.
Okay. So what we want to know is how far do we have to go this direction to get back up to 71?
Okay.
So what we do is we have a V of 0.25 because we're trying to get from 70.5 back up to 71. We have an S somewhere, an S or a G. I don't know where it is out here. Don't see it, but you got one.
Yeah, it's 2.1.
Okay.
What's not showing up? I guess it's just like my annotation.
Okay. And so we're going to solve for H. And that H becomes this distance right there.
Gotcha.
And so that way we'll have a point here. We'll have a point here. Both of those points represent 71. So we can then connect them.
Yep.
Once we have them connected, of course, we can then just extend that line on down.
Totally get it. That helped.
No problem. Did we answer your other questions?
Just like if you could just take a look at my FFEs, that would be fine.
Sure.
Just to make sure that it'll be okay. I doubled up
63, 63, 64, 64, 70. Yep. Those will, all I'm doing is, you might have noticed, I'm checking the back ones because the front is so flexible. You can add ramps and stairs and all sorts of stuff in front. So what that means is that this 65 is in some way, shape, or form going to have to come up and hit there. And then if we zoom in so I can actually see the contours, because I did discover that they are all there. Let me make sure I haven't missed any. Scroll down, Stuart. Okay, so that means that our 66 can come up. Wow, things are going to get tight here.
Yeah.
This has to stay right there, must stay.
Yep.
Can actually go up like that. So, and wherever your 60, your next one is, it's not here yet, but when it comes across, it'll come across there as well. I think you have been way premature in putting these guys in.
Yeah, I just threw them in there. Don't
do that. Don't do that. Yeah, I know. I throw them in so it feels like I've got work done. Don't do it. Never, 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 never. Because why?
Well, because they're going to change.
They're going to change. And are you going to remember which ones need to change?
Well, I know that they're kind of all going to need to change.
Yeah. So after you change 8 of them, do you know which one is the 9th?
That's true.
Trust me, I've been there. It's an easy way to trip yourself up.
I gotcha.
So anyway, what happens then is that means that our 64 contour can actually come all the way up, and you got them all at 64. So that can run all the way over like that. And then the 63 can come. And so your swale is actually going to come around here. You're going to have a change, the spot elevation there as the slope changes. And then hopefully that all will work out. If you find this to be a little bit too much grading that you don't want to do, you can always just bury the back of that building and say they don't get a walkout, and that was their fault for renting that unit.
All right.
I have a quick question about the angle. If you go to the parking lot, the point you chose on the center line, it can be anyone?
It can be anyone, and in this case, I happened to pick his 71 because his question was basically, where does the contour line go? So I picked one that had a contour line. So I could have picked the 72 or the 70 or this 71, which I think is right here. But it could be any point at all. I just happened to pick the even number because that's what you guys are trying to figure out, is where the even number contours go, or whole number contours.
I think.
I have a question about the contours at the bottom. So the 63, didn't you say like we can't go near the tree, or is that near the trunk of the tree?
You cannot go inside the drip line of the tree. It would be preferable, frankly, if you could, stay outside of it totally, maybe come back here. But that's just a matter of moving a contour line.
All right.
In this project statement, there is no requirement that you stay 5 or 10 or even 50 feet away from the trees. You have to stay out from under the tree. But the further you can stay away, the more pleased we will be. And our being pleased with you, it doesn't give you any extra points, but it's still, nice for us. Any other questions on this one?
Nope. Thank you, Stuart.
No problem. Yeah, you with us? Check my who's in the room.
I think that's mine. Yeah.
Okay. You have any questions on it?
Yeah.
Yeah.
Plot. Oh. Okay. Can I just ask him because I have it?
Absolutely.
Okay. So, my first question is: do we use the imaginary center line like we did in the parking lot grading exercise?
Yeah. I think there's a center line drawn in there.
Okay. Yeah, because for the grading exercise, we kind of drew our own one.
Yeah. But so this is the center line, and it's that there. That just answers that question. Yes, that is the center line.
Okay. And then my second question was, sorry that my numbers didn't plot, by the way. I think a couple other people had that problem.
Okay.
But my second question was, how do we calculate the contour lines outside the curve for the crown?
Right. Yeah. So what I tend to do is I will measure this distance, and whatever that distance is, I'll take half of it and I'll offset this line over so that there's now another line here halfway between. Okay. And the reason I do that is that it's an easy way to say, all right, this contour comes across, it runs along the face of the curve, and halfway between, that's where it comes off.
Okay.
And I like to do it visually like that because you leave it to the math and I'll mess it up. And so what happens is I then go the same distance here. Again, I can offset the line. I have to go back and delete the line afterwards. And then that's where that contour is going to come off. That also tells me, however, if I look at this distance here, that distance there to there should be the same as this distance here to here. So let's get a few of these lines out of the way so we can make sure that you understand what I'm saying. This distance A should be the same as this distance B. The reason that's useful is that I can then use that distance to come up and offset another line. And that is how I know where this line is going to be, because there may be a line that comes across and I'm not sure about that. So let's take that out, because it looks to me like you've got something doing this. And so it's going to come off here. And I'm actually going to turn it further up here. The reason is I want water to run down to where the gutter is, because the water's already running to the gutter. Mm-hmm. And so if I've got the same situation over here, and I'm not totally sure that I do, but I think I do, that water is then going to do like this. So that water is going this way. So again, this distance is still this distance, we'll call this one C, even though it's the same as all of them, is the same distance as A, B, and C. Then I can come out and do another one out here if I want, and say, all right, distance C again. And that allows me to get that same slope going out on both sides. Now, again, you notice I haven't put any numbers over here because this slope on the right-hand side is more than likely different than the slope on the left-hand side. And the reason—
yeah, the one on the right's at 3% and the one on the left's at 2.2.
There you go. Is you've got different starting points down there that you have to match up to. So I've given all these slopes the same over here. I cannot simply take those and transfer them to the other side. That would definitely not work. I'll have different slopes on the other side. But once those slopes are in on this side, again, that distance on this side is going to be the same. Whoa, drawn poorly. You understand what I'm saying, though, how I'm trying to lay that out for you.
Mm-hmm. Okay. Another question I had was, how would we direct water away from like the buildings, especially the spot in between them? Would we use these kind of contour marks that you've
Yep.
drawn off
Yep,
the ground?
we're using what we've drawn. So take a screenshot of that real quick. And then I'm going to just simply change colors here and draw, because what we want is we want the water to be running away from the buildings at an angle like that, just like it's running away from the center line of the parking lot. And then what's going to happen, of course, after we do that, is we're going to put all of that water into the curb there, and we'll put drop inlets or curb cuts at the corner of the curb at the low point. And frankly, it's going to be the same on the other side. You know, we've got, you know, water running that way. And then of course, you know, we've got water running to these corners. And that's the basic drainage pattern.
Would there be a drop inlet at each one of those corners?
Yep, there sure would be. There would be drop inlets there, 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 down there. There'd probably be two out here, depending on how you design that.
Okay. And would we still need a swale if?
You're going to have some sort of a swale going around the building on this side. And you're probably going to need some sort of swale going around the building on this side. And you could have a swale running this way, or you could have a wall going across and just have a slope running there.
Okay. And for the swale, do we like draw a center line going around the whole building?
Absolutely. Absolutely.
And then, but we just cut it off where we need to.
Yep. So it, you know, as we go down here, it's going to stop moving somewhere around there and somewhere around there. They're not going to go beyond that. They don't have to be very big swales.
Okay.
It's going to go like in between the buildings and the parking lot, the center line?
There's no swale running down between the buildings. And
so the center lines are going to be, so we're going to have like two separate center lines on both halves of the, or both sides. Okay.
Correct.
So the two lines you have drawn now, would those be like concept for center lines?
Those would be concepts for center lines. Cool. They're going to be over there somewhere. They could be longer, they could be shorter, they could be further away, they could be closer in. You can add walls to make the contours stack up easier.
And would the swales have to follow the 2% slope requirements that we?
Nope, swales are allowed to go up to 10%.
But they have to be greater than 2%, right?
Greater than 2%, or 2% or more.
Okay.
And in this case, that's not going to be a problem at all. We've got a lot of slope on the land here.
Right. My second to last question is, for the ramp leading up to the house, should that be placed right in front of the handicap markings, or should we put it to the side of it?
You've got options there, and the reason is, if you were to add a sidewalk, let's get a different color so it shows up and make it a little fatter. If you're to add a sidewalk, you know, across the back, then your ramp really could be anywhere you want up to the building, because I can come down that ramp anywhere I wish, you know, and I could come down here and then go down like that if I wished. It makes more sense to have the ramp right in front of the building that is ADA accessible. Mm-hmm. It's not a legal requirement though.
Okay. And then my last question is, on my HPS on the parking lot, would it, from the way it's looking right now, is kind of gonna be like the third parking lot we had on the previous exercise, where they kind of formed a diamond? Would that be all right? With
that's totally fine. Yeah, I'm looking at your parking lot and I see exactly what you're talking about. That, you know, it looks like that might do something like this.
Exactly.
Right, and that would not surprise me. Now let's zoom in on that because, you know, there'll probably be a couple of y'all that have that issue. Whoa, that was quite a zoom in, Stuart. So you could have, you know, a small triangle running around it like that did not come over and hit the curb, but there will still be one on the curb that comes back this way. And the reason is we're going down 3 inches from the center point to the curb, but of course the curb goes up 6 inches. And so there's probably going to be a contour along that curb, even if this contour in the middle does not attach to it. So this one could be independent from it, but there's still going to be a contour along the curb. Does that make sense?
Would that just like follow the half distance rule that you used before to draw the?
Yep.
Okay. Yeah, that makes sense.
Yeah, and there'll be a couple of folks that have that in their drawing. So, anything else on this one?
No, that was it. Thank you.
All right, thank you. I didn't get that one closed off. Are you with us?
Yep.
Wow, look at these color-coded questions. When adding sidewalks after the parking lot, do I include spot elevations at the corner of the sidewalks? Yes, you do. Doesn't that suck?
They will be the same elevations as the parking lot corners.
Well, yes and no. So let's go down to this one here, for example. And I'm going to imagine that you've got contour lines running through here. Wow, that's not right, but anyway, let's see if I can get it a little closer to correct. Where is your, okay. So if I've got a contour line running this way, it's going to run down to about there, and then it's going to go off. And this contour line, I think there's one coming around here, and it's going to run around here and then come off. So why am I pointing that out? This is going to get a TC and a BC, and that's perfectly fine for the sidewalk right there. That's all it needs. But you need one here. To get that one, you're going to take this contour line, if it's exact, and simply find that. And if you don't want to do it that way, then you can always figure out you've got 3 slopes out here, to be truthful. So you've got your main slope running this length, and then you've got your 3-inch crown slope, and there's actually a steeper slope running this direction. So you've got all 3 of these as options to use for calculating elevations. So if I know this elevation for the top of curve, bottom of curve, I could use this. Whoa, let's get what I want here. I could use this slope inverted the other direction to calculate that spot. That's one way. So the answer is yes, you do have to calculate all those additional spots. The good news is it's not particularly complicated because the slopes are exactly the same as what you already have on your sidewalks and ramps.
Wait, okay. So I'm kind of confused. Why wouldn't that be, as I also have a similar sidewalk, why wouldn't that be, that point be the same as the TC? Shouldn't it be like this at the same level as the top of the curb?
No. And the reason is there is a contour running across here. Okay, it may be running here and back, whatever. But the point is there's a slope running this direction, just like there's a slope running this direction. And that means that same slope is running this direction. So if that's the case, then anything along this line would be the same as the TC. And frankly, anything on the other side would be the same as the BC. But that point there is going to be a different elevation than the corner of the parking lot. So no, you cannot make this spot elevation and that spot elevation the same, because that would be flat, and they're not flat.
Okay.
If you happen to have a spot elevation right there that I just put in, then those two would be the same, because the slope is running this direction. So if the slope is running that direction, anything on a line this way is the same elevation.
So we could calculate that point using that, like that, the 2% on the center line, and then the curve. Okay, I see.
You got three different slopes you can use to calculate it. Cool. You can either use this slope, the 2%,
calculate it on the bottom of the curve, and then on the top of the curve of that, and then
you could use the slope that's here, except that it's the other direction, and that's probably the one I would use, is that one. And the reason is, if I already know the elevation right here, the quickest way to find the next elevation over here is to simply use a slope that lines up with it. Does that make sense? I'm late.
I still don't understand what that slope would be like.
So you know there's a slope running this direction, correct?
Yeah.
Okay.
Well,
whenever you have a slope running that direction, you can also calculate what it would be in those other two dimensions, other two directions. So remember when we talked about, how to find the contour line out here in the middle? I said you come down 3 inches. Well, if you're coming down, that means there's a slope there, right? And then you go up that same 3 inches. That means there's also a slope this way. So out here in the parking lot, we can use these guys to calculate slopes.
Yeah, so like what are, like, there's just like 2%? Like the same as the center
one? This one's 2%, which is the same as this one.
Okay. Okay, but not the one going down?
The other one's not going to be the same. And then just to make your life more complicated, assuming that there's another contour here, then it's easy to see that we also have a slope running this way.
Okay.
So, I mean, any time you have a surface that is at an angle, there are normally at least 3 different slopes you can use on that surface for calculating spot elevations. And I've just circled those 3 different slopes. They aren't given to you. You have to figure out what those slopes are, but you can use those anytime you wish. They're all
okay, I guess that was my question. Yeah. How do you find, like, specifically for like this one? Like how find that one?
So you find out what this distance is here. So that becomes an H. The V is 0.25. And so you're going to solve for S. And that's how you find it.
What are you finding here?
He wants to know what the slope is for the crown.
Okay.
And the reason he wants to know that is he wants to use that same slope number going the other way to solve for this spot on the corner of the sidewalk, because that's the fastest way to solve it.
Yes. Professor, for the corner next to the sidewalk, do I need to find the 2 corners of the sidewalk, or is the corner from the parking lot sufficient enough because it has top of curve and bottom of curve?
So I think you're talking about right in here.
Yep.
Yep.
Yes.
You only put 1 spot elevation there, and it's top of curve and bottom curve. The fact that there's 6 inches of curve and there might be a slope, you totally ignore that, because in all honesty, all curbs have a slope anyway, and they all slope towards the parking lot. And that's a level of detail that you do not worry about.
All right, thank you.
My last question about that was, when you said that H, where, like from the center line to where, like do we just do it to like the start of that parking space, or?
You can do it out here if you want. It's going to be the same.
Okay, yeah, that helps, because
I'm
not sure where to draw that H.
I totally understand.
Professor, for that slope, like for mine, I just used 2%. Is that wrong, or I should calculate it the way you just said?
For this slope here, I don't know if the 2% is correct. I haven't calculated it. My guess is that if you're just using the 2% without calculating it, the chances of it being right are pretty much 0. By the way, this is the correct placement of a spot elevation. That is incorrect placement.
Oh, okay. So you recommend calculating?
Absolutely. I would go ahead and figure out exactly what that slope is, because it's going to be useful for you. And again, 2%, I doubt it. You know, anyone bother to do the measurement right here? What is that measurement? I know you guys have your auto.
Where?
From the center line to the edge, to the inside curb.
Oh, I think it's like 11.38, something like that. Wait, here, let me check real quick.
Whatever it is, that is your H. And your V.
Yeah, 11 feet.
It's 11 feet. Okay, so H is 11. And V is 0.25. So what is S? I got a bunch of you in the room that I know can calculate that. I got 19 people, all with calculators. What's S?
I believe 2.2, 2.3.
2.2 or perhaps 2.3. My guess is that you've got some decimals in there.
Yes.
So what is it exactly?
It is 2.272,72727.
Wow, I deserved that, didn't I?
Yeah, yeah, that's what I think too.
When I'm doing my calculations, I will use the 2 digits for the calculations. I will label it to 1 digit, but I'll use the 2 digits for the calculations. So this is S for the calculations. For the slope, when I label it here, it's going to be 2.3%. That makes sense?
Yes.
Now, that 2.3% is going to be useful to everybody. And in fact, this 2.27 is going to be useful to everybody, because we can use that to determine the difference between these 2 little points on the sidewalk here. Right?
Yeah, so
so
the lower
slope is different on both.
So this one, it'll be the lower one. This one will be the higher one. Oh, that was interesting. Because the slope is running this direction, but I'm using my 2.27 as my slope going this direction in order to determine the difference between these two.
And then you add values going towards the arrow.
Say again?
So you would add that to the whatever value you get as for the H. I guess you would add.
You don't add to H's. You add to V's if you wish. So let's go to the other side where we got a little more room to talk about this. So let's presume that our unmasked text, sorry, I had to point that out, is correct in elevation. And we want to know what this point here is. We would take this distance. How wide is that sidewalk?
5 feet.
5 feet, okay. So our H is 5. Our S going this way, our S is 2.27. because we use that level of detail for our calculations. You don't have to, but I do because I'm just one of those, people that likes to do it that directly. And so I'm going to get a V out of that. That V, I will add that V to this number here to get that number there. So this spot elevation on the corner of that sidewalk will be the 70.76 plus whatever that V is, because I'm using a slope running this direction, which we know is 2.27.
Oh yeah, that was, so if it's at the, I guess if it's at the base of the arrow, wait, so if we add, it's there and subtract.
We add when we're going uphill, we subtract when we're going downhill.
So the arrow is pointing down.
Arrow,
so this should be plus, then this should be minus.
No, arrows always point downhill.
Wait, so I had it right the first.
Yeah. So let's go over to this. Let's go over to this one, for example. Point A will be lower than point B. Because the slope here is actually running this direction. I'm running out of room for arrows. So that point A will be lower than B. As a matter of fact, as long as we're sitting here staring, looking at that, there's also a need to do one of those puppies there. And Wu Hong posted a handout of how to do that. So I'm not going to go into that into a lot of detail right now, because we're going to run out of time if I do. Let's go back over to these questions. So there's need to be a swale on the right side by the townhouses like the left side. Yeah, probably so. There will be a small swale running over here somewhere. It probably will not be as pronounced as the swale you have on this side. And the only reason is that I've done this project enough times that I know it doesn't need to be that pronounced. However, it could run all the way down to here, depending on what you do with this. So for example, if you bring that 65 all the way up here, and I have to look at your elevations and see if there's any need to, nope, you buried the back end of that thing, so there's no need to. How about this one here? That one's at 62, and you got 63 for your steeper one. So I'd probably, let's see, the 63 is right here. And so I would probably go with the 63. So I would go with the 5% there. This one, there's no hope, unless we put a bunch of stairs, which you can. And if you put stairs, then we can raise the elevation of that one. Your question was about swale. Sorry, I couldn't resist myself. The spot near the driveway and the road, do they seem to be in the right areas? Is that over here?
Yeah, you kind of answered that in the beginning of class.
Okay, cool. Love it when that happens. How do I determine which FFE to pick for the townhouse? Haha, we just did that. Yay. The one that fits the back best. So in this case, I said you're 63 because that fits the contours back here. Okay, in reality, I could pull this 62 up, but then I've got to get it back down before it hits this tree over here. So it'd have to go up, down, back, over like that. And nah, we're just not going to play that.
Yeah.
You could, but I'd rather you not.
Okay.
So that was a perfect timing for that question.
Professor, I have a question about that though.
Yeah.
I'm not sure because I'm trying to understand the concept. I'm not seeing how 63 makes sense because the house should be higher than the parking. Shouldn't it?
63 is her lower FFE.
Oh.
This is her upper FFE.
Okay.
So she's going to go with 72 and change, and then she's going to go with 63 and change.
Oh, okay. Makes sense though. Thank you.
No problem. In the final, we need to include a walkout basement. Would that be the same elevation as the lower FFE? Yes, that would be the same elevation. And then you would put about a 2% slope on it. And this one would not have one unless we had stairs in the front, but if you had stairs, you would do the same thing. And if you did add those stairs, then this contour would probably come and hit there. And then the rest of the contours, 63 is going to have to work its way up. Might want a wall here. And then 67 is going to have to work its way up. And then 68 is going to have to work its way up. Because remember, we have to keep that 68 in the middle. And then 69, squeeze while I sneeze or hold it back. Yep, no sneeze, we're fine.
How do we show the walkout basement in the back?
You simply show the spot elevations. And whoa, that was interesting. Let's take that out. There are a couple of ways to do it. And in the assignment, we said you had to have at least a 10 by 10 pad back there someplace. So you'll put a little piece of concrete back there. And then you'll have your FFE for your building. And then you'll have a spot elevation for that pad that will have a 2% slope running away from it. Now, frankly, what a lot of folks do is they say, you know, I'm just going to have the whole thing as a concrete pad. And the reason is that then I only have to do 4 spot elevations, and that saves me a lot of trouble. And I think that's a very practical way to do it.
So it can be larger than 100 square feet.
It can be, yeah, minimum.
Okay.
I've had some students that actually bring it all the way out this way and make this giant party space. And I had one student even add a deck on it. I don't know why, but they just wanted to add a deck.
So that's the only thing that we need to have from the back?
Yes. Well, you have to have that. And of course, you have to have all the contours that are back here.
Yeah.
But that's all you need for the back end. So let's talk about, you know, this one, for example. This spot elevation, that can be BW. This spot elevation can also be BW, and it's understood that it is also the elevation of the pavement. You will need a spot on the wall for TW, and you will need one more spot on this side for the other BW. That's because whenever a wall has a corner or joins a building, there are 2 elevations, one on one side of the wall and one on the other side of the wall, and they are normally not the same. That's the reason the wall is there. But of course, at the end of the wall, that one only needs 1 spot elevation. So
is this one also the same? Is this one also going to be the same as the your bottom FFE?
This top one will be the same as the bottom.
Okay.
FFE.
Yeah, that's what I wasn't sure about the one further one.
But the one further out would be at 2%.
2%, right. Okay. Makes sense.
The one on the left side, isn't that normally like 4 inches, 5 inches below the other one?
The one on the left side.
Bottom wall elevation.
Can you draw for me?
Yeah, sorry.
Doesn't matter. Don't get
that one.
That one would not be lower. It would normally be higher.
It would be higher?
Yeah. The reason is the purpose of this wall is more than likely to hold this soil back.
Oh, okay. And
so let's go to the other corner. You're going to need a spot for the corner here. You're going to need, you know, if this was a patio, you're going to need a spot for that if we drew the patio right where it is. And you're actually going to need a bottom of wall right there. And that's one of the reasons that students will often say, I'm just going to put the patio right back here. But you're still going to need a spot on both sides, and you're going to need a TW. We can come back to these in a minute. This is getting into detail that wasn't part of the question. I want to make sure above all else that we get through everyone's drawings. Have we answered all of your questions on this one?
Yeah, I actually have one more question. How would the contours work in between the two the townhouses? Would there not be none because of the retaining wall? Okay, never mind.
There'd probably be 5 of them in there or so. And also remember, and I've talked it to a couple of folks, you know, you've got, you know, this happening up here. Somewhere you're probably going to have another contour here to make sure that water is draining away. And that means you're going to need spot elevations.
Okay.
And all those elevations. You notice I gave these a curve, and that's just to make sure that the water drains away from the building. Other folks will run them straight across. The water still drains away. It's acceptable either way.
Okay.
And I love the fact that you found all these little spots out here. Somebody checking on AutoCAD, I believe there's one right there. And I believe the same on the other side. There's one here, and then there's one right there. Don't worry, we weren't going to, you know, dock you bad for not finding those. They're well hidden.
Wait, Stuart?
Yes.
How did you get the V 0.25?
The V 0.25, because 0.25 is equal to 3 inches. And we have a 3-inch crown.
Okay, can you do the math real quick? Because I keep forgetting how to do that one.
No problem. Let me go find a fairly clean part of the drawing over here. So we know that there is a 3-inch crown. And so we're going to have contours that are going to be doing something like that. The difference in elevation between this point in the middle and the outside is going to be 3 inches. You with me?
Yep.
Okay. 3 inches is the same as 0.25 feet. Because 3 inches is 1/4 of 12. And 1/4 is the same as 0.25.
Oh, all right.
Got it?
Yeah, thank you.
Hey, I messed up on that, I think on Tuesday, didn't I, Tyler? I don't remember if I did or not.
I think you said like 0.4.
Yeah, 0.4. It was.
Yeah, I think I was saying, okay, 1/4, so that would be 0.4.
Yeah.
Yeah, wasn't that a lovely moment?
I mean, I didn't know how to do it in either way, so.
And I remember I kept saying, but Tyler, you need to do the math yourself. You need to do it yourself.
I did do the math, and I remember getting the same thing, but I think I was just because you gave me that number.
I know. Okay. Are you with us? Wow, look at these beautiful questions.
Yeah, I'm here.
All in color. Fun, 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 fun. Okay, let's start with questions. How do I calculate the contours between the two sets of buildings where I place the retaining wall? I understand the shape it should be, but I do not understand how to calculate it. Hey, here's the good news. You really don't have to calculate it. Just keep them 5 feet apart from one another.
So oh, okay.
And then you put a label on it that says, you know, 20% max. So because you're not on pavement, you really don't have to calculate them that exactly. You can if you want. And if you want to calculate them that exactly, you would figure out what your bottom of wall is going to be on this side of the building, which would, you know, be 4 feet below your 71. And then you would figure out what that slope is. And I might actually put that spot all the way down the bottom here. And then once you have that slope, you can figure out exactly where they're going to go. That is a perfectly acceptable method as well.
Wait, so we don't need to?
You know, if I say you don't need to, then I'll probably get in trouble. So let's go ahead and calculate that slope.
Okay.
So you don't have to find the numbers on the building?
Well, what I'm doing is I'm calculating that slope, and then I'm figuring out based upon the top and bottom spot elevations where the contours are going to hit the building.
Okay.
Now, in the real world, would I do that? Only if it was really important to me.
Okay.
You know, is it important to you? Yes. And by the way, these spot elevations do not go on the porch. They go on the ground.
Okay. My other question about this was like, I know the shape is like this, but how do you calculate that?
That one, okay, yes. So for that one, you've got these contours running across here, right?
Yeah.
What I do is I simply take that distance and I offset again to get that line. I come over here, I take that distance, I offset that again to get the next line.
Wait,
that
what
way,
what distance are you doing?
Okay, let me run it back. So you have these contours coming across here.
Yeah.
You don't have them coming across yet because you're not quite sure that that's really what you do. But I'm telling you, yes, that really is what you do.
Okay.
And now the question is, all right, so where the heck does this next one come in?
Mm-hmm.
What I do is I take this distance.
Oh, okay.
I then offset that same distance, and wherever it hits the building, that's good enough for me.
Okay.
Over here, I take this distance, which is different, and whatever that distance is, I offset that one. And the chances are it's going to wind up being a little off center. Make sense?
Yes.
And that's how I would do it. Then right there, I would be sure to add a high point. And what happens then is that all of the drainage on here is now the same.
So would that contour be the 72 or the 71?
That would be the 72, I think. It would be really helpful if we had labels on these. And so I'm going to presume.
I have the labels are on the other side. Sorry.
Aww.
But I think I understand.
This is the 71 contour that I just drew in.
Yes.
And this is the 71 contour.
Yes.
Which means that, yes, this would be the 72.
Okay. And it doesn't matter that there's no 72 on the building?
Well, this elevation is probably now wrong, as is this one, because they have to be above 72.
Yeah, okay.
Now, let's talk about that, because we got trouble there.
So right now I have those at a 2%, but I think if I raise them to a 5%, they would be above 72.
Or to make your life easier, you just might add a couple of stairs.
Okay.
And I hate to say it, at this point in the project, making life easy is important.
Okay.
So 72, which means this becomes 63 and back. And this becomes 63, 0.54. Which also makes your life a little easier and back too.
Okay.
You got a capture on that because I'm about to move it.
Yes.
Come on. Give me my mouse back. Can the paths be straight lines or can they be curved? If they are all ramps, and what is the appropriate slope? Well, for now, I would make all the paths straight. And the reason is less work.
Okay.
You probably also want to include a sidewalk across the front here.
Yes.
And I'll tell you the reason with, you'll be doing curved paths later on. And so if I have a curved path, what happens is that every place there's a tangent, I have to have a spot elevation. And that is normally enough to discourage me from doing it unless it's a real good design solution, which it often is. And you guys also know that I'm not afraid of spot elevation, so I'm happy to do it that way. But for this project, I would say don't worry about it.
Okay. And for the path or the sidewalk, does it have to go across the entire parking lot?
I think it's a kind thing to do so that no one has to walk in the wet grass or the snow.
Mm-hmm.
Is it in the requirements of the project? No. So let's keep that in mind. I drew that sidewalk in because It's very helpful and useful, but it's not something we're grading you down on if you leave it off.
Okay.
How should I draw contour lines for above the parking lot? So what's going to happen up here is these contour lines are going to connect to one another. So you've got your 71 coming across. If I can get my pin back. You've got your 71 coming across, and it's going to connect over here. And then your 70, it's coming around, it's having fun. I'm a little confused about what's doing there, but not too confused. It's going to go over there like that. Your 69, and at that point, you're going to try to cut them as close as you can. And your 68, again, I would probably do a mirror image on that 68, so it closes on itself like this. And I'd put a drain here and here, which means the 68, wherever it is, I'm going to have to move my 66 down. I'm going to move my 65 a little bit. I had to fit my 67 in, and I had to fit my 68 right on the, almost on the back of the curve.
Okay.
And then of course, it's going to come down here. That 68 is going to connect in. We got to make sure we know what the numbers are. And so 5, 6, 7, 8, that is the 8 going under the tree right there. So that 68 is going to come and hit here, and then it's going to come up and back like this. And you're going to play that game with the rest of them until you don't want to anymore. Should I keep the swale on the far right one and add one on the far left? How can I tell if they need to do so? The answer is yes, you're going to need a swale over on this side. Hang on, gotta get my tool back. You're going to need a swale over on this side, and you're going to need a swale over here, and it's probably going to come back this direction.
Okay.
This thing here probably needs to go away.
Okay. I was just like confused because if I put the swale like closer, then it doesn't like the high point.
Yeah, well, I'll show you another option here if you're curious. If I can find my mouse. You actually can, let's back out of some of that. This swale could come up like that, and we could create a swale that goes this direction. That's an option as well.
Okay, but then doesn't these like pathways become bridges?
No, because this is actually coming up to like here.
Oh, okay.
In the parking lot, we're doing a bunch of drainage running this direction. And then that drainage would simply do like this.
Okay.
If we had a curb cut. The other option, of course, is that the drainage can run down around the building, but I always want to discourage that when I can. But that's going to be next semester. We're going to talk a lot about safe ways to do drainage next semester.
Okay.
And if I can get my mouse back. How do I draw the contour lines above the parking lot? We just did that one. Swale, we just did that one. How do you draw the contour lines for behind the buildings? I know I can have a maximum of 4-foot retaining wall, but how do the contours connect to it? Is that behind or between the buildings?
Well, I think I was talking about between the buildings, and I think you answered that. Oh. But for behind the buildings, are they just connecting back to their?
Yep, they're just connecting back to where they were. So for example, that's going to be a walkout basement. So this 65 is going to have to come up somewhere and maybe hit there. And then you've got a 62, which is tough. I'd rather you go up. And I think we already decided to do that. That was going to be a 63 now. And so that 63 contour, the 64 is going to come up and hit. The 63 is going to come across like that with a 2% slope running away. And that's the reason I said your swale may wind up running around this far. In fact, I can see that you might want to, work that swale a couple of times, exactly where do we cross to get a nice swale created down there.
So with the swale, how do you determine where the high point is?
You actually get to choose where it is. And what you will discover as you're doing these contours that are, coming around and this way, there'll be another one that comes around and off, and it can hit the building here, and you can simply choose to start your swale up in that area. It's really up to you.
Okay.
And you could choose to do 2 swales if you want. You could have one going this way and then one going down around the building. And again, next semester, we're going to talk more about that. We're going to try to run the water away from the building as fast as we can, because when we're running, the water down right next to the building, there's always a question and concern, about this pinch point as you're getting water close to the corner of that building, which you always want to avoid. But we're going to deal with that next semester. Right now, you just have to make sure that you're not running water against the building or against any of the walls.
Okay.
So for example, we know that you need to put a little more information in these corners here.
Mm-hmm.
Make sure that that water actually does run away from those corners. Good to go?
I think so. Thank you.
My pleasure. Wow, lots of spots. Are you here with us?
Yep.
Do you have any questions?
Yes, I do. So
Okay.
my question is, I didn't write on there, but like I did the parking lot slope, and I just don't really sure, did I do the spot on the curb right or not? Like,
I question that slope. I think that slope, if you have a 3-inch crown, is going to be different than what you have drawn. Because I think we figured out it's going to be a 2.3% slope sideways, or maybe a 2.27 because it's a 3-inch crown. Now, the question is, given the amount of work that you have in here, what's the easiest revision?
so I'm still not sure, like, how can I like be sure what is slope look like? Like,
okay.
Yeah, I just, at first I do the center line and decide all the point on there.
Right.
And then I just using 2% slope, then get a bottom curve and top curve. So
okay, so in the problem statement, we've said that there is a 3-inch crown.
3-inch crown.
And that 3-inch crown is going to be equal to a 2.27% slope.
Slope, okay.
But with the amount of work that you have done, I'm trying to figure out where we lose the least amount of points. Do we just say, oh, I messed up on that 3%, on that 3-inch crown, and because I don't want you to be redoing all of these calculations at this point. So I think that would be the best thing to do. I would add a note in the drawing to make sure that people know that you are aware of that error. Because going back and redoing all of this work is not going to be a good use of your time.
Okay.
Now let's go back to your question, which I've forgotten because I focused on the 3-inch crown. What was your question again?
Yeah, that's my question for the parking lot, and then for the ramp, like the ADA or something accessible, is that the way to doing it? But I'm not sure, because the middle part, the central part, like the slope, I didn't write on there, but is smaller than 4.9%. So I think that should be steeper, right?
It's going to be steeper than the 4.9%.
Right. So.
And I think you just have to go back and rerun your calculations. One of the things that I do see that I think is probably an issue is you've got these at the same elevation. And that means that that surface is totally flat, and you don't want flat surfaces out there. In fact, you've got that one, this one, you got all of these at the same elevation. And it's fine to have these at the same elevation, but what you're not showing, and we need to make sure that we get this information, is we really need the spot elevations out here.
Okay.
On the ground. And, you know, I wouldn't even put this one here. They're not needed because they are probably the exact same as the FFE. Yep, they are. And so the fact is this one is going to be lower than these two right here. And that's the reason that your slope calculations don't work out the way you want.
Okay.
Ideally, the easier way to do this would be to add a sidewalk all along here and then do your ramp in this area here.
Okay.
And then you can simply have one piece of sidewalk coming up to the building this way. That might make things easier for you.
Okay. And for the building, the bottom point of the building, is that like I put 71.08.
Show me where.
Like over.
Just go ahead and draw for me. Okay.
So is that the elevation right or not really?
That looks correct, but that means that this one is not.
Oh, okay.
And the reason is you really need to put your contours in here.
Okay.
Without your contours, you're having a hard time visualizing what's going on, because my guess is that you've got a contour that's going to be coming across like this, over like that, and back like that.
Right.
And that means that we're at 72 there already. And if we're at 72, because I'm taking that number right there,
right,
then that building is too low.
Too low. Okay.
Right. And even if I bring it back a little more, because if I go there, there, yeah, that's still going to be too low. Okay. Also, for some reason, oh, there's the double line. Okay, the double line for the curve is there. You guys really need to work on your line weights here to make sure that these show up in your PDFs, by the way. So that's my concern there, is that if that's 72, then that building is too low. Okay. What I would do is I think you need to raise all of your buildings.
Okay.
And you could raise them with a set of stairs, or you can increase the slope. I think you might want to put your ramp for your ADA over here somewhere, but you've got more space to work with than you do at the other one. The other thing that I need to check that I'm concerned about is that if this is a 61, then that means you need to pull your 61 contour up there, and we cannot do that because of the tree down here. So this is the 61 contour.
So this is totally too low. Like,
right, you can't pull that up there because it kills the tree.
I'll raise for 2.
Yeah, you could pull the 62 up if you wanted to.
Okay.
And then the 63, and also be aware over here, be very careful about how your contours are hitting the building, because those contours are pushing water into the wall. So those contours need to be turned.
Okay.
And if you need to make your wall longer, that's perfectly fine. The other way to do that is to back those contours further up. That would make it work.
Okay.
Now we got water draining away. We definitely have a swale down there that you need to add in. But I think our first concern is we got to get the elevation of those buildings up substantially on the side. And on this side as well. Because this is the 62 62 contour right there.
Mm-hmm.
Now that's the 63. That's the 63, 64, 65. And so you might be able to pull that 63 up in front of that building, but you don't want to try to pull it all the way up to this building.
Mm-hmm.
So that means that this is going to have to be 63 and change.
Mm-hmm.
And then your 64 might be able to come up. And then your 65, your 66, your 67, your 68. That'll all work. Don't worry about a walkout basement on this one. That's just going to be too much trouble.
Mm-hmm. Okay.
Keep going. What other questions do you have?
I think that's it.
Okay, I think you really need to get your contour lines in there right now.
Mm-hmm.
Because they're going to tell you a whole lot about what's going to be working and what's not going to be working.
Mm-hmm.
So, you know, for example, this is your 72 and this is your 71. The 71 is going to come down here and that's where it's going to connect. That's great. 70 over like this might come off there and connect in.
Mm-hmm.
69 back to there. Yep. Of course, your 69 is up here. So let's recognize that 69 is going to be coming down like this. And so it probably is not really going to connect much into the middle one at all, into the existing 69. On the other side, it will have to, of course. That 69 is going to be coming down and it's going to connect into the other 69, but probably back here someplace. So you probably won't be able to work it out in that space.
Mm-hmm.
By your 70, and it's going to come back and connect in. Probably not there because it has to get all the way over to the other side. Because the 70 over here is here. So it has to get all the way over to there.
Mm-hmm.
Does that help?
Yep. Help a lot.
All right. Tyler, you still with us?
Yes.
Oh, look at those new contour lines.
Yeah, they're pretty. I don't know. I don't know what to think of them. They're kind of. They're really rough, and I really. Yeah, that was one of my biggest questions. Was right there. I tried doing that, and I just couldn't understand that how to
let me tell you how to do it, Tyler. You got to let me talk to you.
Sorry.
Take that distance there, whatever that is, do an offset here, same way. And then hopefully it's going to wind up right there. It should, because you got that distance. The other option, to be truthful, is you could just take your line that you have, take this line, copy it from this endpoint to that endpoint. It's going to stick right there. Take this line, do the same thing, copy it there to there. It's going to run there, and then do a mirror image. You follow me?
Wait, so is it still going to be the same like angle like that? Because
Sure
I
is.
just copied that entire thing.
Yep.
And then tried to paste it here.
You got it.
And it makes like when I tried to do like that distance thing.
Don't worry about it.
When I did it.
Just
do
the copy thing. What you got is fine. Your copy method is perfectly correct.
Well, I don't think it is, because when I did the upper one, it crossed through here. Because when I did the distance to make sure it was the same here,
okay, so
it made them cross. And
let me explain why I think it's correct. Because you've already figured out these 3 points, correct?
Yeah.
In fact, you started with this one right here. That's a 69. We gave that one to you, correct?
Yeah.
But it's non-debatable.
Yeah.
So,
although,
just take this, copy it to the center, and then do a mirror image to the other side, and then connect them across there.
Okay, so then from there, that's my question. So is that a closed contour then?
That is a closed contour, absolutely.
Okay, that helps a lot because I was so confused on how.
That's a closed contour through there, which means that that 69 contour, there's going to be another one coming around the outside here. Okay.
Oh, yeah, because that's what I was missing. If you scroll back down to the side of the building.
Yep.
I missed. I literally don't have anything like right here. I had no idea because there was a 69 here, so I was like, well,
So
which one am I supposed to use?
Come down. It's going to hit the building. That's one way to do it.
Okay. So we don't use this, the one that's close to it.
No, that one's going away totally. The existing 69 is history.
Okay.
The other thing that you can do if you want is you can bring this 69 up this way and then back and join in order to start to create a swale going this direction if you want.
Oh, yeah. So is this shape that I have right here? It's probably not true.
It's up to you. You've got a lot of flexibility there. This is not a swale line up in here, so get rid of it.
Yeah, yeah. I should just start it like.
You killed my tree.
I did?
Yeah.
Wait, which one's the contour number is that?
That's the 68. 68. And it's going to come out down here and then up. So the 69 can come in here. 68 can come in here. 67 is going to get pulled down a little bit. And the 68 is going to run like this and around. And this 67 is going to run around, and the 66 is going to run around, and then you're going to run out of room. But that's okay, because you're allowed to make them as close as a 4 to 1.
Oh, so 5.
Okay.
Maybe 5 feet. 5 feet close, I think.
So now you got to squeeze these puppies in. And I would advise you just start doing 5-foot offsets. And it could be that you have to move this one a tad. That's acceptable as well.
So where am I attaching those to?
Well,
the one's over there.
Okay. Around and attached. So you can see I've attached them to their start point over here. And then let me get back over where I was, clear that. And then they're going to attach back in over here.
Okay. Oh, wait, I'm going the other.
I don't know where that one goes. You'll figure it out.
Can you guys zoom out a little bit just so I can see the entire thing? Because I was confused. Because I was connecting them to lower. So it's not correct to connect them to the lower. You scroll back down. See the way I have them connected, like the 66 and stuff. So it should be going.
Those are correct.
Wait, they are?
Yeah, those are correct.
So it's just like the 6 up to the 68 that should be going like back that way. Okay.
Yep.
Okay, so then I think that's so my other main question was, so this is a 60, so this bottom FFE is a 64. But my thing here is a 62. That's not right.
Well, you got a 63 there also.
Yeah. So I'm kind of confused. I don't think this lash contour is correct.
So why don't we 2, 3, 4.
Oh, I'm missing the 70.
I don't think that one's correct. I think your LPS is wrong.
Yeah, okay. I was just putting LPS in.
Also, be very careful on that corner, Tyler. What am I going to do there? What am I going to points off for on that corner?
The spot elevation, is it not? It's
water running against the wall.
Oh, so it's, yeah, right, okay. So it should be more.
It breaks my heart to take those points. Yeah.
Okay.
Maybe.
Yeah, I mean, these are just the rough, like with the.
Yeah, maybe you just want to, work that out again up here, so that, you're coming out, and then maybe add a little wall there if necessary. Make sure that you've got plenty of room to play because you got.
Yeah, because. Okay.
And don't forget, when you get done with this, you've got to make these look like contour lines on landscape.
Yeah, no, I know. I'm gonna make them.
So here's my question: if this is 64,
yeah,
why are you bringing the 62 up here?
Because I need to have 9.
But you could have it over here.
Wait, but then they're.
In fact, you're bringing the 61 up, aren't you?
No.
Why are you bringing the 60? Oh, there's a 62.
No,
okay.
The 62 should be the last one, but I don't know if. So you're saying that it is correct, but it can be further down. It should be further down.
I'm saying it's not even needed. And let me tell you why. This is a no walkout, right? So this is all wall. That is all wall right there.
Yeah.
You can put as many contours against that as you want.
But I know, so we need 9. Don't we always need 9 for the sides of the house?
Let me finish, Tyler.
Sorry.
We got a 64 right there. So that means we need a 64 out here. So that's a 4. All right. And here's our 64. Right there like that. We don't need to move any of those other ones. Here's our 65. Let me change colors to make it easier to see. You're going to get pink contours. Oh, you're going to get them fatter than that, though. Here's my 64. Here's my 65. There's my 66. There's my 67. It's really that simple. And I'm just tying them right into the numbers right there.
Mm-hmm. But so for this 60, I just thought that it was a rule that we had to have 9 contours stacked up against the side.
You will.
So 65 is the last one.
Running all the way around the building. Okay, so you take a quick photo of this because I'm about to move it.
Okay, hold on.
You got it?
Yeah.
Okay. And let me just get a whole bunch of these lines out of here.
Oh wait, actually, could you zoom out so I could get the entire?
Sure, but when I zoom out.
Oh, right.
So what I'm trying to do is I've got so many lines on this. I need to work my way back and delete these lines. Wow, we were talking a lot here. Let's just get rid of that. That goes all the way back to someone else's drawing. Hang on. There we go. That's what I want to get rid of. Okay, so now.
Yeah.
Go way back, way back. Okay, so I'm going to work in the purple again. This is a 64, which means the 64 contour can come right across like that.
Does it need to touch the retaining wall?
I don't know. I have to check over here and see if it needs to. Yeah, over here you're down to 62, so it's going to have to hit the retaining wall.
Wait, what does the 62 have to do with this?
Well, because here's your 64 right there. In fact, you probably need a 63 over there, but we're going to get to that in just a minute. Let me finish this side first. And so here's your 66. Here's your 67. Your 68 is coming across there, going through the tree, coming out, coming up like that. And then you've got to fit in your 69. And then your 70 may move over to here. So let's count contours, because I said you had to have 9 of them on the building, right? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, so they can be, well, wait, that's not a contour. That 9th one is not a contour. That is technically, yeah, okay.
That's also not a very well done 8, but yeah.
Okay. Get a picture, because that confused me. I thought that meant 9 on the side, on specifically only on like this side. It could be anywhere on the building.
Anywhere on the building.
Okay. That makes sense. Okay.
That gives you a lot more flexibility, doesn't it?
Yeah, Yeah, that clears a lot of things up.
Yeah. And you know what? I wouldn't make that walkway so complicated because every place you put a corner, you're going to put a spot and you're going to hate spots.
Right. Okay. Yeah. Just make it like straight.
Yeah. Just straighten it out some.
On this.
Okay. Are contours in this swale correct? Is there a better way to do it? Yeah. There's a better way.
Yeah.
To
We
do
just, yeah. We just went over that. Kind of.
Let's find my cursor again. Are my corner elevations from my back of the wall? Oh, by the way, let's.
I think we also kind of covered this. I think I know what I need to do. Except
you got it first off, Todd. You got a screenshot of that?
Yeah, I got that one. Yeah.
All right.
I think we kind of went over that. We went over the porch.
We did
the porch stuff. So the only thing I had was you said that this bottom of wall had to be higher.
Well, I'm looking over at the other side. You got a 63 right there, a 62, right?
Hang
on. I'm looking here and I see a 62.
Maybe if you.
So that means that.
Oh yeah, because it's a yeah. Okay.
So I'm going to need a 63 contour, and then a 62 contour. And so let's talk about where those contours are, because this 62, it's going to be coming across. And what do you got there? You got a 62 there, yeah, and then it's going to be coming down like that. So that's a 62. And here's a 64, but we have no 63. So I think you need to redo these and just redo their numbers. 3, 4, 5, 6, 7, and then add in an 8. So that this is a 63 right here. And so what that
okay. Yeah, that makes sense.
Is that 63 contour, which we had coming up over here, it's going to have to somehow hit that wall. So you got a 64 there, which means this is going to be a 64 contour. But you got a 3 here, which means that wall probably needs to stick out a bit more.
Okay. Right. Okay. Yeah. Oh, okay. Yeah. But so for that 62, if you go back over, how do we calculate like how far it is away? So it's like just 2%.
2% slope away from the building. And so what you'll find is that it actually will do a little jog like that.
Right. Right.
That could be questionable there. That 60.
Yeah. No. Again, I just copied it. I know it's not right.
Yeah.
Well, like distances in.
And Tyler, get these things off of the corners.
Yeah. No, I just did it so I would remember to
label
all my corner elevations.
Okay.
So, but the distance I meant like for like H, like how. Oh wait. So if we.
Well, if you're doing this.
Okay.
You know your V is 0.35. You know your.
Oh right, 0.35, not 6.2.
And so you're going to determine what your H is.
Using, okay.
Now, the other thing I want to point out is I don't understand up front, and I don't think you do either, why your 71 is running where it's running.
Wait, could you, I just want to get a picture of the bottom half real quick before we do that. Can you zoom out a little bit?
In?
Out a little bit. So I can just see, yeah, how you get the other side. Right, thank you.
So up on the other end here, you know, I agree with this contour, and that one I'm fine with. This one I'm okay with, but this one has me concerned. And I think you're trying to get to the corner of the building here.
Yeah.
I'm not sure why.
So because I was really confused with, this is me doing the thinking that we had the 9 contours on the side of the building. No, that's why I did that. But now I know that it could just go.
Elevation you have right there.
What?
You've got a 70 elevation right here, right?
Yeah, that's
right there. So if that's 70, I'm going to suggest that this contour simply comes across and hits this wall.
Yeah. Right. Yeah. No, that makes sense.
Now, let's be aware of what that means. That's a 71. And okay, we're above. That's fine. It's going to run along the wall just like that. And this elevation here, those puppies there are wrong, as are these are wrong, because you're basing them on the FFE. And the whole point of those spot elevations is to tell us what the ground elevation is.
Right? Should I move it in so it's, I think that's referring to the porch, because the porch should be the same elevation as the door.
Don't label the porch. We know it's the same FFE as the building.
Okay. Okay.
You may have to put a top of stair in here.
See. Oh, okay.
And that is where you would put that elevation for the top of stair.
Mm-hmm. Okay.
Yeah. Okay, so lower elevation for drainage.
Yeah, I figured that out. That was just a note to myself.
Note to yourself to do it. Okay.
Yeah. Okay, so I guess if you zoom out a little bit, I kind of tried to connect this like 69 and stuff and 68 to the contours on the road. I don't think that's right.
Yep. Let's see what we got there.
So I went like 25 and then connected it. 25 connected it because they're 50 feet apart.
Yep.
So is that?
Yep, that looks correct.
So even though should I be doing this since it's off?
We're not gonna mess you up for that. You don't need to go beyond the property line, and also don't forget to take this line off. Delete it when you're finished with your drawing.
Yeah. I know. I'm still kind of working.
Yeah.
So I can stop like here or
just leave it
here.
It's fine. You just leave it. It's fine.
Okay.
That was a little close there. So why did you tweak these back the other way by the building, man? Come on.
Oh yeah, because this is before we talked. Yeah, no, that makes sense. Yeah, curving them. These are just like literally with a polyline. I know I'm going to go in and make them more curved, but.
Okay, doke. What other questions do we have? How will contours cross the sidewalk? I've answered that right up here.
Yeah. I guess that makes sense. Okay. So it's this 72. Actually, now that I think about it, it's actually going to be, so this is a 73. So this would be like more like a 70. This would actually be 73.5. This, I don't know if this is actually a 72 anymore.
We don't know yet because I think we're missing a contour here. If this is your 70 and this is your 71, then I would expect to see a 72 around here. And now I'm going to go over to the other side and see. So this is your 71. And your 72 would be about, your 70 about there. So I'm going to guess that this is going to make a connection about like this. And the reason is I'm trying to get the distances to match up. Does that make sense?
Between this, okay, right here.
Right. Yeah. And so, yes, this would be a 72 contour. And so that elevation at 72.5 is fine. There would be no 73 contour.
Okay. So I guess my question is still that helps with the with like the location of it, but like where is this? The highest point is like a 71. So like where's this going? Like is it just wrapping around the building? It's like where does it like connect into?
Yeah, the 72 contour, it has a really good time. It does this.
Okay.
Then it runs along the back side of that wall because that spot elevation, those two spot elevations are incorrect, just to let you know. Then it runs around, comes around. So basically, it's a great big closed contour.
Okay, yeah. I was going to say, it's kind of actually higher than the natural grade. Okay, so what were you saying with these being incorrect? Because I did 0.5 down from the FFE.
So why would you do that?
Don't we always do that? Half foot down from the.
We have to have at least 0.5, but that brings up another excellent question. If this is a 72 contour now, if we're going to say that's a 72 contour, and I'm changing colors now so we can point it out. If that's a 72 contour, we got a problem with that FFE. So that FFE has to go up.
Great. Okay. So then it would have to be like a 70.
Going to be probably a 72 and a half, at least.
Okay.
But of course, when we change the height of those buildings, we have to do it in 8-inch increments.
Oh yeah, so it's not okay. Yeah, that's going to be
a royal pain in the butt.
So it has to be 71.8 plus 0.8, so 72.65.
I don't know. I'm not going to work out the math with you right now. But what
is that still too low though? 72.65 or is no? It's still higher. That's
probably high enough.
Okay.
So one of the things that I do want to check on here is your handicap accessibility. Because, hang on, I'm going to move it so I wouldn't draw it there because I'm going to move this around a little bit. If we have stairs in these buildings, which we do right now, come on, clear for me. We have stairs there, stairs there, stairs there. That's done great and back. But can we eliminate some of those stairs on any of them? And I'm going to show you a way to do that. All you have to have is one of these things ADA accessible.
Yeah, which will
be that we put a ramp out to there. That's one option, because I want to make sure that we get this one ADA accessible if we can.
Yeah.
The other option that we've seen done before, and this is really kind of fun, is a sidewalk like that. In fact, you know, let's do them in straight lines because we certainly don't want to make extra work for ourselves.
Yeah. Actually, so before
and by joining those two, it makes it easy for us to then have a ramp that just goes this way, because we're really elevation there. We could also have a ramp that goes back the other way.
Yeah. Okay.
So I just think you probably want to figure out how you're going to get that accessible done, because your buildings are really high, and that makes things work out, you know, nicely in the back. But
yeah, I see what you're saying.
Even in the back, if I look at it in a little more detail over here, if that is a 64.8, then that 64 contour could come over and down like that. And those units could both have walkout basements.
Yeah, I mean,
I'm not sure why you pulled all these up previously, but I think that, you know, we've already determined that they don't need to do that.
Yeah. No, that was just me trying to fit them on the side. That makes sense.
A little bit of stuff you got to figure out. And then the other thing I want to do, and I want to point out to you and to everyone else who's listening, the spot elevations out here, you got to find the tangent points. And the tangent points are there. You got that one there, you got that one there. There. And you got those two. And then I'm going to take you to the center. This one doesn't really matter a lot, but believe it or not, there are actually two of them in there. And we're not going to bust anyone for not finding them.
So back to the ramp thing. So how, I'm still confused at how I should go about doing this.
Well, you've got lots of options actually of how to do it. And, you know, one of the options is that you run a ramp out of.
Yeah. Okay. So let's just go with that idea for an example.
Then I would just do that and then make the entry point for the ramp out here at the corner. Now, the bad thing about that in terms of design is that as long as you have this as your accessible area, then I can park my car right there and I can get out of my vehicle and I can go out to that ramp and I can get up to that building.
Yeah.
But that,
yeah, I'll move it over.
But that means one vehicle only. You know, if I get out of my car here, then I have to get out into traffic to get to it. But that's acceptable for now. We only required one ADA accessible, and it could be with one vehicle. That meets the law requirement. It's not a great design, but it meets the law requirement. And we're not requiring that you have them on both sets of buildings. But you could, on this side, do the exact same thing. You could have your accessibility spot here, and you could run this all the way out. The question is, could you get enough elevation to get up to 73? And I doubt that you could. That's going to be
without overdoing.
But I would check it. Remember this one. This one we're going to go up a bit as well.
It's up to 72. So that is also my other question. So how, if you scroll down a little bit, so if I'm changing this, that means it's changing the lower FFE.
Yeah.
And will these be pushed? Will these be pushed down?
No, I don't think you have to move those down. But
so what's going to change then? If I'm changing that FFE, what else would be changing?
Well, what's going to happen is that this unit is lower. If I can get it to draw for me, come on. Hang on, gotta go through this stupid little process again. So this unit is lower than that one, which means that this contour is going to come up, and then it's going to go down, and then it's probably the 63 contour. That's going to be a 63, and that's going to be a 62 because you go up a bit, which means that this 63 contour might just come right on across. Because basically what you did is you went up a foot. Of course, you've got to adjust that to 8-inch increments, which means you can go up 8 inches or you can go up 16 inches. And it's up to you. You get to make that choice.
So is this, by this 60, wait, so is this the 63 or this, which one were you talking about?
One, but then I realized after I put it in that you've got this 63 already coming across.
Yeah, okay, I was going to say.
So you may as well just continue it on.
Yeah. But would that going across there, does that disrupt this patio?
No.
Okay. And then does it just stop there, or do I connect it? Because I think this is also a 70.
Well, you got a wall right there, and you got the other 63 coming up over here.
Yeah. So it'll just run around on the wall like that.
Yep.
Okay. Everything.
Professor?
Yes.
There's something that that happened in the roundabout when you if you scroll up, if you don't mind.
Don't mind at all.
Yeah, I don't get what happens to the grading over there.
To the what over there? The grading?
Yeah, over here. Wait.
Okay. So what we did in his case, And we'll draw it again to make sure that everyone can pick up on it. We took come on. We took this line here, that line there, and then we simply repeated it right there. So you can see that makes sense. Does that make sense to you so far?
Yeah, I kind of get I get the method.
Yeah.
But sometimes in grading, I know how to do something, but I don't understand it logically. I just wanted to know what happens there. How does the water go?
So what we're doing now is we're going to do a mirror image. We're going to put a center line in here.
Yeah.
And the slope is going this direction. And on the other side of the line, the slope's going to go the other way, because we're going to do this, a closed contour and a closed contour on this side.
Yeah, what's the closed contour? We're just closing it so the water like fills up there.
So for example, you see how this contour runs along the curb and then comes off?
Yeah.
And this one runs along the curb and then comes off?
Yeah.
What's going on in this area is that it's running along the curb, but it doesn't get off, it goes back up. And so let me see if I can get some.
And that causes the water to concentrate on a specific place so it can drain.
Yep. So the water's going here and it's all going to get stuck right there.
Okay. So the purpose of that is to drain the water at a specific place.
And then we're going to put a drain here. And the real reason we're doing this is that when you're driving along this thing and you're going, whoa, zing, and back out, it's really nice to have this slope going down this direction as opposed to having the slope going out the other way. Because if there's ice or something and I'm driving around that circle, I'd much rather have it slope towards the center. And so what we've done in this case is we have put a line right down here, and this slope is going that direction. But on the other side, the slope is going the other way. So we have basically created a swale that runs down on this side and a swale that runs down on that side. But because there's a curb, we have to put a drain inlet there to catch the water and let it out.
Okay, thank you. That makes sense.
So if I was in section going down, come here, Muska. Good day, Muska. Oh, that doesn't help, but we'll just delete that. And so if we were doing a section line across here, our parking lot is sloping down, and then we're sloping it back up. Then we got a curb, and then we're going off down. So this point right here is this mirror line right there. So I'm driving, in section I'm driving, and then I do my circle and go back. And that's what I'm doing here. I'm doing my circle and then I go back.
Okay, I get it.
It's tough. And by the way, there are about 5 standard ways to do these turnarounds, and this is just one of them. There are many other ways to do it.
Okay. Do you mind me sharing my screen? I have other questions.
Let me see, Tyler. You done with your stuff?
I have 2 more.
More? Okay.
Yeah, just 2 quick ones. I just realized.
And then we'll open it up to everyone.
Okay. Yeah. So right here, the 69 we were talking about. I just realized that I was taking the measurements. So I started from here, and I did like just the 0.3. I'm using this percent, and then I started with the whole number of contours. And this distance is not. This distance is a little. It should actually technically be a little bit past this point.
Right, except you have to start at 69. That's what we decided for you.
Okay, so what should I do? Because I think I started here for some reason.
Okay,
so
then
how should I?
You're gonna have to readjust these guys a little bit.
Okay.
So start from the center and work your way up, and just readjust those a little bit. It should be a pretty small adjustment.
Okay, good. And then my last thing was right over here. So this 68, comes here and comes like this, goes around.
What does it do on the other side?
Yeah, what's it going to do on the other side? How is it going to connect to the?
It's going to connect to the other 68.
But that's off. It's off the property line.
That's okay. So you're just going to run it down like this, and then you're going to say, all right, it connects in there.
Okay. Because I thought we weren't supposed to grade that outside of that.
You're not required to, we're not going to hold you accountable for anything past this line. That's the property line. And so if it runs down here and you connect it back there, well, whatever happens there, that's all Vegas rules. We don't really care.
Okay. Okay, thank you. That was
my pleasure. Questions. Tyler, you got a shot of this?
Yeah, actually, can you? Okay, thank you.
You good?
Yep.
All righty. I will stop sharing and let someone else share.
Can I share my screen?
Absolutely.
Thank you. It seems like there's an issue. It's telling me it's paused. I'll try again.
Okay. Push come to shove, you can send it to me in an email.
Okay, thank you. Oh, here we go. Yeah, is it showing?
Yep. Might as well turn that big layer box off.
Yeah, you can see it now?
I can see it.
Okay. So yeah, I had one question. So I did the concept. I have it in my other PDF, but that's not now my question. I know how it's gonna look like, but after I did my concept and I had a meeting with Wutong and Wuhang, sorry, and she showed how it's gonna look. But for this one, I discovered that my what is it called? My that this is wrong with you, the slope percentage, and that I calculated. That means I need to redo my parking.
Okay.
The grading here. So my question is, after I find the percentages, what is the best way to begin grading the parking lot? Is it by finding the TCVC everywhere or finding the contours on the center line and then finding the angles, then finding the TCVC?
I think the contours first is easier, but there are people that will do it the other way and say that their way of doing it is easier. So it's really up to you, but I prefer to find the contours first.
Okay, and in order to do that, I should find the contours on the center line first. So this is 71.55. I can go to the 71 and then mark these and then do the angle as you showed us in the beginning of class, right?
Correct.
Okay, perfect. So I need to try out this today. My other question is, last time I don't know if you remember, I showed you this elevation. It was 71 point something. Mm-hmm. And it was too low because this was 73 and this was 72. So,
so you raised it?
Yeah, I added 4 stairs. I didn't draw it yet, but fine. I know for a fact that every two stairs is 1 foot.
Correct.
So I added 2 feet.
Good.
And I got that. It seems good.
Yes.
And then I was like, why not have stairs in each one of them, just to be on the safe side? But I feel like I raised it here like too much, right?
I think you did. I would make your elevation for that one exactly the same as the one next to it.
Those two?
Hang on, let me see if I can get my drawing up. I would make these guys the same.
Oh, okay. In terms of...
I don't see a reason not to.
Okay, so probably remove the stairs from here.
Yeah, I'd probably remove the stairs from there.
And maybe here too, and then keep this one.
My guess is that your last one at the end is probably going to need the stairs.
Yeah, so yeah, it seems like this one and this one might need stairs, and those two.
I'm pretty sure that this one will need stairs here. And then beyond that, it's really up to you.
Okay, sounds good. Yeah, I guess I need to try it out.
Yep.
And okay, if you give me a minute, I have a few questions in my notes. So.
When did you meet with Hu Hong?
Me?
Yeah.
Yeah, today at 8 in the morning.
Yeah.
So that's why I need to, after she gave me feedback, I need to fix a few stuff. But I just had some questions that were based on things you talked about today. For example, she told me to have this as the ADA.
I agree.
Yeah, so I need to, I can't show it now. So we only need to have one that has an ADA access, right?
Correct.
Okay, perfect. And for the walkout basement, if I extend, one thing confused me is this part of the grading. Like, I still didn't get to it. I want to finish the parking lot too. Might be a bit behind, but I was confused at the beginning, but it's fine.
Don't get too far ahead in the parking lot because it may have to change if things don't work out in back, but or at least the walkways may have to change. But go ahead with your question.
Yeah, true. That's why these are might change based on the parking lot.
Yep.
So the walkout, what confused me, like I know I might have asked that question already, but what should we have in the back here? I know for a fact that I'm gonna extend a wall here to connect some of my contours. I might not need that, but I know for a fact I can do that. Yeah. If I do that, in order to make a walkout, do I need to close it in?
No, the wall can just go straight out. The wall.
Okay, so I can have a wall here.
The wall can just go straight out, no problem.
Oh, sorry.
That's all right.
Yeah, straight out here and straight out here.
Yep.
And that's it. I'm just confused about the basement walkout.
So the basement walkout, basically you take the lower FFE and then you do a 2% away from the buildings to figure out where the next contour line is going to be. And it's really that simple. I mean, it probably makes sense to, show, a space there if you wish, paved material, and then spot elevations on the corners as you've seen in the other critiques, and obviously a line across there.
Yeah.
But it's actually pretty straightforward because what happens is the walkouts are based upon the lower FFE and you just use a 2% slope.
Perfect. And that needs to be like, how many of that should I have? Is that up to me? How many walkouts?
I think you have to have at least 2. I would say you could easily do it for these 3, and that one might be questionable.
Okay, but I can still have a wall here.
You can still have a wall there if you want, but don't do the wall just because you can, because it could.
If I need to.
Right, because it could be that these contours, simply come up, and then hit the building, and maybe you don't need to have, a wall there. There are lots of ways to do that with or without a wall.
Yeah, true. Because if I put a wall there, it might stack up between the tree and the house. And
yeah.
Okay, yeah. I wish, like, I have a lot of questions in mind about things that I still didn't do. So, a
lot of folks have been busy with studio, and they've got a lot of work to do on this.
Yeah, it's fine, but I kind of understand it today, and I can get back to the video there. Thank you.
Excellent. All right, sir.
So I'll try out the parking lot now. Thank you.
Mind if I go next?
Doesn't bother me.
All right, I'm going to share my screen. I just had like 2 quick questions. There we go. All right. So I was just putting in the contours, and this is how it ended up being in the middle. And I remember we talked about this, and it doesn't look right, and I don't think it is right.
It's pretty darn close.
Oh, really?
Yeah.
So
what you're going to have, and I'm going to see if where are my annotation tools? There they are. Let's change the color there. And hang on, I'm just changing my settings here. So this contour, hate it when it does that. This contour is going to run like this. Then it's going to run out this way, some distance, and then it's going to come off. This is going to go around this way, and then it's going to come off.
Yep.
This contour, that's the one on this side. The other one is going to simply run along there and come off. And it's going to close on itself.
Okay. So it doesn't close in the parking lot, it closes.
No. And the reason is that what you've got down there is you didn't quite touch the curb there. And so these two contours are not going to quite touch. Does that make sense?
Not exactly. So
okay, so let's imagine in section.
Oh, so it's like so there's like in between there's a little gap, and then there's another 72 is what you're saying.
Right, exactly.
Oh, I got you totally. Okay.
Yeah. And then this come around this way, off out here somewhere, around this way and off out there somewhere. And then you're going to take them this way and go back that direction.
Yeah, the bottom ones, that ones I totally understand. I just wanted to make sure that was okay.
Absolutely.
And then, so like you were talking about like finding the spot elevations based on the contours. And I know that you go, so I don't want to move.
No, that's all right. I'll clear
all right. So I know that like to calculate them, I remember when we did in exercise 10, it was like you go perpendicular to like say you went perpendicular. However, I think I got like points off totally for the exercise 10 because I did it wrong somehow. So I just like wanted a little refresher.
Okay. So if we know that this line is perpendicular.
Yep.
We take the length of that line, and the length of that line, so that length from here to here, that becomes our H.
Okay.
The elevation that we start with here is known. That's a 71. But what we need to know is what is this slope, because we're going to try to solve for V. And until we know that slope, we cannot do anything. The way I find that slope, because I'm lazy, is I take the H over here. So I take this H, and I know that the V up here is equal to 1. So then I'm going to solve for S. That gives me the slope or the gradient. Yep. Once I know that, I can use that over here as my S, and then I can solve for V. That V is the difference between that point and this point.
Okay.
That's one way to do it.
Yep.
I think it's a simple way to do it.
Okay.
And we could do the exact same thing here. I can run a line out like this. And the difference is to get that point, I'm adding, whereas to get the previous point, I'm subtracting. Now, to do that, I must be absolutely sure that my contours are correct.
Yep.
So let's remember this slope is not 2%.
Yep.
It is 2.27.
Mm-hmm.
So I have to make sure that that is in there and that these are correct. If that's the case, I believe that this distance, I believe from memory, is 6.25, but it's your job to check it.
Yep. All right. I think that makes sense. Yep.
Super.
All right. Thank you, Stuart.
My pleasure. Anybody else?
Yeah, can I screen share?
Sure can.
All right. Okay, can you see that?
I can, thank you.
Okay, so basically I met with Wu Hong and she told me to try to put the contours in.
Yep.
And my lines are like a little off because originally I did like this length 0.25 and then you said 0.4. So I was like, oh, he's probably right. And yeah, so I need to fix all those and like do some recalculations there.
Yeah, I'm not sure I'd go with that 0.4.
Yeah. But like for the most part, like this is like my 72 contour. Like, is that generally correct? And I like which side would need like a swale added to it? Like,
okay. So I think that your 72 needs a little help because I see a 72 here and I see a 71 there, 71.9. My guess is that there's going to be a 72 contour running across here somewhere.
Okay.
I'm not totally sure where that is, but I can see you've got a 71 here. Is that correct?
Mm-hmm.
And then you've got a 70 here. So I am just guessing based upon those distances that one is over there. And then I see this one here. And I know there's going to have to be another one down here somewhere.
Mm-hmm.
And so that's why I am making a guess that there's going to be one about here.
Okay.
What that does, we're still good there. That means that these elevations, we probably need to look at some of those again to be sure.
Okay.
I'm really concerned about that elevation right there. That 72.36 does not seem right to me.
Okay.
And I'm not sure how you determined that. So one of the things we have to be sure that we understand is that those spot elevations are on the ground, not on the porches. And that looks like you've got that figured out correctly.
Mm-hmm.
But I'm very suspicious when I see that spot elevation, that spot elevation, that spot elevation, that spot elevation, all the same.
Mm-hmm.
That doesn't make any sense because it needs to drain away.
Okay.
So I think what you did is you probably took this, subtracted 0.5 from it.
Yeah.
That's how I'm going to do all my spot elevations. Remember that 0.5 is a minimum, but it's not an absolute. They're not always 0.5.
Okay.
And it looks to me like you did the same thing over here.
Yeah.
And so all of those spot elevations are based upon subtracting 0.5 from the finished floor elevation, which is not the way you want to determine those.
Okay.
Instead, you're going to determine them just like you did in your parking lot, frankly, because you've got to make sure that we've got a slope that's going, away from the building here, that's running the water, off that way. Sorry, that was a little. Got water running off that way, just like we have water running off this way.
Mm-hmm.
And it all runs into this area. Same thing over here. So you need to solve those contours in front of the building to help you see the picture. And that's probably what Wu Hong was trying to explain to you.
Okay. And also, how do I like grade the sidewalks? Because I marked where like the contour lines would be, but like they don't really, because like 71 is on like all of them, or like almost all of them, I think. And like I don't really know how to like connect that line there.
I think you need to, frankly, change all of those spot elevations to 0 zeros because none of them are correct.
Okay.
And so your 71 contour, what you should do is like, let's imagine that I drew some paint in the middle of your parking lot right there. I hate it when it does that. I'm going to draw some paint right there. You can find any of those points very easily off of those contour lines. Now, you can find the elevation for any of those things. the fact is, you can think of these walkways almost like paint on the ground. You want to keep the sidewalks as much as possible level with the ground. Now, granted, when I say level, the ground is sloping, but you don't want those ramps to be in much contrast to the ground if you can avoid it. And where you need to use stairs, you use stairs.
Okay.
But I think until you get the concept for between the buildings and the parking lot worked out, you're not going to be able to see how that's working.
Yeah. Okay.
So what were you saying with like the elevations not being correct, the 0.5 down?
So she just finished floor elevations on these, and then she just subtracted 0.5 and made all of these spots 0.5 below. And that is because at one time we were telling you guys that, you know, on your very first grading project that you did, you had to drop at least 0.5 from the finished floor elevation.
Okay, so what's wrong with that?
But that's a minimum. So for example, you know, over here, she dropped 0.5, right? You see what I just drew?
Yeah.
Okay. And there's no way that that's going to be a 72.8 elevation there. And she knows that because she's been putting her contours in, you know, right here. So she knows that's not what it's going to be. But she simply put that number there because somewhere in her memory, it is, oh, you dropped 0.5 for the spot elevations for around the edge of the building. That was true when we had just one slab and there was no change in elevation going around the building.
So what should it be? Because I think I did something very similar.
Well, it needs to be based upon the lower FFE.
Oh, well, for that side, but okay, so I'm talking about like, so how is this, if this is 0.5 down from, like this side should be 0.5 down from this.
No, Tyler, it should not be 0.5 down. It should be a minimum of 0.5 down.
Okay.
No less than 0.5 down. I would say one could easily be 3 feet down, 2 feet down.
How do we determine that? Like what, how much down it should be?
You determine that by figuring out what the ground is going to be out here. So you've got these contours in. And from those, you can then determine. So for example, if this is a 72 contour right here, this is a 71, and this is a 70, then we know that that spot elevation there is going to be just slightly above 70. And we can actually calculate.
Okay, how do we calculate it?
Well, we know the slope. Let me change colors again. We know this slope right, it always does that. I haven't figured out why. We know this slope right here because she's given it to us.
Right.
And try to make that same slope along here. Well, we don't have to make it the same slope, but it makes the project a lot easier if we do.
Right.
So we have basically 3 different ways that we can calculate that spot. We can use the, excuse me, we can use the purple slope. We could take a distance back from the contour line, or we could take the slope that we have calculated, if we have calculated it, the one that goes that direction. So the land is maintaining its same slope. We're just choosing to measure either directly down or at angles that are convenient to us along the edge of a building.
Okay, so if we were to use the pink one, that's our S or G, I guess, variable. And we're trying to find V.
Correct.
So what would be the H? Like where would be, how did we get the H?
You simply measure it on the plan.
From where?
from wherever you're starting from. So for example, let's.
So for this one, like where would we be starting, I guess?
Well, I'd probably start over here if I could, or I mean, any of these. So you have to have a point of starting.
Yeah, that's what I'm trying to figure out. But if they're all, if I have all of those ones that are correct.
Okay, so she, for example, she came up the building this way at a 5% slope. And that gave her an elevation right there. So you could start from there and go that direction if you want. But you've got to have at least one point established on the building to do it that way.
Okay, so we have to have a, okay, so and to, okay, so then how to establish one point, how would we, I guess, do that? Would we just use the same method that we used for like the sidewalk?
Same method that you use for establishing your FFEs. You know, you went down this way, you jumped up the sidewalk, and then you went up the other direction. And once you have one point established on the building, you can then work your way around. But I think what the easier way to do it, in all honesty, is to get your contours in there and get them in there accurately, and then they become your guide.
What do you mean?
Well, so for example, you know, in our parking lot, if we put a contour in here and we know that contour and we know the next contour, then we can find any of these points by simply taking a distance from those contours and using the slope between them. We can use the exact same method in front of the buildings once we have the contours established. That's not the only way to do it. I just think it's the simplest way to do it.
Okay. And will this recording be uploaded after class?
I hope so. Okay. It's going to take it a while to save it, but then it should be.
Okay. Yeah.
Sometime after lunch.
Thank you.
All right, guys, we're past class time. I'll see a few of you in office hours, and I'll see the rest of you next week.
Thanks, Stuart.
My pleasure. I got to make sure I save this recording, which means I need my mouse back. Where's my mouse? I think my mouse, it either needs new batteries or less cat for one or the other.